We're going to have to set up a proportion in number 9 in order to find that missing side. And a reminder with all of this, we're looking at 3 different triangles, and we're going to figure out which 2 of those triangles we can compare. The first triangle is just that large triangle making up the entire shape. But then we also have a small triangle in here, and we have a medium-sized triangle over here. And so we've got 3 different triangles. All 3 of those triangles we might be able to identify different sides within them. And so I've got this side 16 marked. Since the bottom altogether is 25, that means this side in there must be 9 as well. That might help us out. And so I look at the small triangle, and I've really got two sides of that small triangle that I know. One of them is 9 and one of them is x. So that would be the short leg, and that would be the hypotenuse. Okay, and then if I look at the medium triangle, there's really only one side I know of that, and that's the long leg, which is 16. Since there's only one side that I know, I probably am not going to be using that medium triangle. If I look at the largest triangle, I have the entire hypotenuse, which is 25, and I also have the short leg, which is x. So again, since I've got at least 2 sides there, like I did with a small triangle, those are going to be the 2 that I'm going to compare in terms of a proportion. So as I set up my proportion, one fraction equals another fraction, I've got to decide what's on the top. I'm going to call this the large triangle. That's always going to be in my numerator. And I'm going to call it the smallest triangle. That's always going to be in the denominator. And then the 2 parts of those triangles that I've been given, one of them was the hypotenuse, and the other one was the short leg. Okay, so now it's just a matter of plugging those values in. Let's look at the largest triangle. The largest triangle has a hypotenuse of 25. And the largest triangle has the short leg of x. That's the value we're trying to find. Okay, so now my numerators are done. Let's take a look at the denominators where I'm identifying that small triangle. Remember, that's this guy right here. We said that's x, and this is 9. Okay, so it's got a small triangle, has a hypotenuse of x, and it's got a short side of 9. That is the proportion that we want to initially set up so that we can solve for x. Once we've got that, we're good to go. Now it's just a matter of cross multiplying. X times x, in other words x squared, is the same as 9 times 25, which is 225. And when I take the square root to get x, if I do it on one side, I've got to do it on the other side. X equals, some might say plus or minus 15, because technically, algebraically, that's true. But again, we're dealing with distances that have to be positive. So x has to be 15 here.